Alright, we are going to continue on talking about mixed numbers, and we're going to subtract some mixed numbers now. Now, when we talked about adding mixed numbers, remember we said that we had to do things like line up our place values, we were going to subtract T-R-A-C-T, I promise I can spell. And the last thing is we have a special process with subtraction, and that is borrowing. But we'll talk about that in just a moment. So let's start off with something fairly straightforward. So we've got something like 10 and 13 sixteenths, and I'm going to subtract from that 8 and 5 sixteenths. Notice I've already lined up my place values. My fractions are over my fractions, my ones are over my ones. I'm just going to go ahead and subtract these two fractions. 13 sixteenths minus 5 sixteenths, I can do that. So what I'm going to do is I'm going to take that 5 from that 13. 13 minus 5 is going to be, it looks like it's going to be 8 sixteenths. And then I can't take 8 from 0, so I go over here, borrow 1. 10 minus 8 is going to be 2. Now I can reduce this fraction, so I've got 2 and 1/2. And we're done. So subtracting mixed numbers is pretty straightforward. We just need to pay attention to where things are. But let's show you what happens with whole numbers when we need to borrow. So remember, if we needed to borrow with a whole number, so borrowing with whole numbers, we would have something like 354, and I could subtract from that, say, 148. I can't take 8 from 4, so I go over here and borrow from our tens place. And I add, 10 ones to our ones place. 14 minus 8 is going to be 6. 4 minus 4 now is going to be 0. 3 minus 1 is going to be 2. So that's how we borrow with whole numbers. It's going to be fairly similar with our fractions, but it's going to be sufficiently different that I wanted to take the time to do this. Let's show you what this is going to look like. Say we've got 8 and 1/4, and I'm going to subtract from that, say, 2 and 3/4. I'm already being nice. I've given us some fractions that have got a common denominator already. But I can't take 3 from 1. So I'm going to have to go over here and borrow from our ones place. Now, what's happening is I've now made this 1 and 1/4. So our thought process is this. When I've borrowed 1 here, I'm adding 1 whole to that 1/4. That's going to be equal to 5/4. Or another way of thinking of that is I've just basically added 4/4 to my 1/4 to get 5/4. And so when I've borrowed here, that doesn't become an 11, that becomes a 5. 5/4 minus 3/4 is going to be 2/4. 7 minus 2 is going to be 5. 5 and 2/4, I can reduce that fraction to 5 and 1/2. Okay, let's show you a different kind of problem with this as well. Let's say we've got something like 24 minus 10 and 5/12. It's really, really tempting at this point to just say, oh, I'll just bring that down. But what this is this is basically equivalent to 24 and 0/12 right there. So what I'm going to do is I'm going to go over here and borrow 1 from my ones place. And then when I do that, I add 12/12 to this. Now, I've got 12/12 minus 5/12. That's going to be 7/12. 3 minus 0 is 3. 2 minus 1 is 1. Let's slow down that action then. Let's show you what that looks like. In this case, when I borrow a 1, that's 1 is going to be equal to that 12/12. This is basically like having a 0 in this place value. So what we're doing is we're just replacing this 0 with 12/12. 12/12 minus 5/12 is 7/12. 3 minus 0 is 3. 2 minus 1 is 1. Okay. Let me know if you have any questions, and I'll see you in the next video.